Hello friends, I'm Swapna Shetty. In this video, we will be able to know to differentiate between ArrayList and Vector, and we will also know about traversing through a collection object using different interfaces and for each loop, and also usage of few map methods. So coming to the difference between ArrayList and Vector. So in ArrayList, no method is synchronized. So when I say no method is synchronized, multiple threads can act on a method. And whereas Vector, every method is synchronized. That is, it allows only one thread to act on a method. So therefore, ArrayList is not thread safe, whereas Vector is thread safe. When I say only one thread can act on a vector method, that means it will not allow other threads. Other threads will be able to wait to act on the vector method. So the performance is low for vector when compared to ArrayList. And moreover, when I declare the size of an ArrayList, say by 10, and if I add 11th element, so by default the ArrayList size would be around 15. That is, it increases its size by half. Whereas for vector, it increases its size by 100%. That is, it doubles the size of the vector object. And we have different classes like ArrayList and linked list. When should we go for ArrayList and when should we go for linked list? If the frequent operation is retrieval, then use ArrayList. So what does it mean is, because ArrayList uses the underlying data structure as growable array. So generally, if the frequent operation is retrieval, we should go for ArrayList. And linked list uses doubly linked list as the underlying data structure. So insertion and deletion operations can be performed easily for linked list. So if the frequent operation is retrieval, we use ArrayList. If the frequent operation is insertion or deletion, use linked list. And how to traverse through a collection object? For that, we can use for each loop. For each loop can be used for either to traverse an array or a collection. So how do we use for each is, this is the way. We declare an integer array, and for int I array name, do the following actions. What does it mean here is, for each element in the array, perform the following statements. So let's see an example of using for each loop. In the same collection samples, I just create another class saying for each demo within the package com.educators with the main method. So I simply create an array whose array A, whose size is 5. So when I initialize an array within the same line, I need not declare the size. I just say 1, 2, 3, 4, and 5. So when I'm initializing in the same line, I need not give the size. So I simply say for each integer I in the array ARR or A, just do the following steps. I am just displaying the values in the array. So when I execute it, you can see all the elements in an array got displayed. So for each loop is used to traverse through any collection, whether it is an array or a collection object. For example, if I take an array list AL equals to new array list and added some fruit or some strings in it like Apple, Dell, Samsung, and I can traverse through the array list saying for string S, because all the types of elements in an array list are of string type, so I'm just taking a string variable here. So for each string yes in AL, do the following actions, which would display all the elements of the array list. Similarly, Apart from for each loop, we also have three other ways to traverse through any collection object, that is using enumerator, iterator, and list iterator. So let's see what is enumerator. Basically used to retrieve objects one by one from the collection object. So to retrieve an enumerator object, we use elements method on the collection object. For example, if v is the vector object, so when I say v dot elements, I would get an enumeration object. So normally enumeration is used for legacy classes. Legacy classes are those classes which were defined in earlier versions of Java like Java 1.2 and so on. So enumeration was also introduced in the version 1.2. And moreover, enumeration is used only for reading operations. So let's see an example of it. So I just create one more class here saying enumeration demo within a package com.educators with a main method. So enumeration is normally used for vector legacy classes. So vector is a legacy class. So I'm just using vector. Vector v equals to new vector and add some elements into it. For example, v dot add of 10, v dot add of some string, say Sita, and v dot add some double value and so on. So I would just display the vector normally like this. So I would get vector as a collection when I display it like within the collection object, that is 10 Sita and 23.7. If I want to get one by one element in the array, I will go with an enumeration. For that, to create an enumeration object, I would use elements method on the vector object, that is v dot elements, which would give an enumeration interface. So just say v dot elements, and since it is returning an enumeration interface, I would capture it in enumeration e equals to v dot elements. So import a package which is of util. Now I would traverse through the enumeration object now. So for that I have some methods like while v dot has more elements would return a boolean value. If the vector has got some elements inside it, it would return true, otherwise false. So if e dot has more elements, then do the following. So for now I'm just displaying, that is e dot using a method called next element. So next element would return the next element of this enumeration. So let's execute. So first we have printed the vector object, and then using enumeration we have traversed through the vector and got element by element, that is element one by one. So this is how we use enumeration. Moreover, if you look at the methods inside the enumeration, we have methods like e dot equals get class hash code and so on. So you can see that we can only read elements, that is using next element method. If you want to perform some operations like adding or removing or adjusting or resetting some values, that is not possible using enumeration. So that's the basic disadvantage of using enumeration. So next is, so that is the reason we say enumeration can perform only read operations. And next is iterator. Again, iterator is the same thing, to retrieve objects one by one from the collection object. So in order to use iterator, I have to use iterator method on the collection object. And this iterator object can perform reading as well as removing operations, but it cannot perform replacement and addition of new objects. So let's see what is removing, reading and all. So now instead of, I create another class saying Iterator demo. With a main method and within com.educators. So say finish. So I just create an array list object here. Array list al equals to new array list and import the package java.util, and now just add some elements. Add of 10, al dot add of 20, al dot add of 13, al dot add of 16, al dot add of 15. So some elements inside the array list. So when I say print al, it would display the collection object, that is array list object, with the elements 10, 20, 13, 16 and 15. Now if I want to traverse through this collection object one by one, then I need to use iterator. For that I simply say a dot iterator method would give me an iterator object. So capture it in iterator interface. Iterator I equals to al dot iterator. Again import iterator from the util package. So once you got the iterator, we can traverse through the iterator by using a method called hasNext. hasNext is a method which would return a boolean value if an element is present in the array list. Otherwise, if an element is not present, it returns false. So while hasNext, that is if an element is present, do the following. So let's say I want to do some processing on this array list object. For example, I wanted to print only the even numbers from the array list. So how do I do it? So for that I can say if I percentile 2, if a number is divisible by 2, then it's an even number. So I just print that even number, that is using I dot next method. Next will return the next element in the iteration. So first, if I dot hasNext returns a boolean, I need to retrieve the element first. So for that I just say I dot next and capture it an integer value. Say integer o equals to I dot next. So here you need to mention o and not I. If it is an integer, then print the value, that is o. Otherwise, do not print. So I dot next, it is asking for a mismatch. Like I dot next basically returns an object, but here we are capturing in an integer. So we need to perform a typecasting, that is add cast to the integer. Then run as Java application. You can see only the even numbers got printed. So this is one of the advantage of using iterator. Like we can traverse through the collection object, get element by element, and we can perform some operations processing on that elements. So this is how we use iterator. And if you look at the methods inside the iterator, we have hasNext, which returns a boolean value if an element is present, and next would return the next element in the object. And also we have a remove method, which can be used to remove a particular element from the collection object. So that is the reason we say iterator can be used to perform reading and removing operations. So can perform read as well as remove operations, but it cannot perform replacement. That is, we never see a method called set method inside iterator interface, and we cannot even add new objects to the collection object. So if we also want to add and replace elements in a collection, we need to go for a list iterator. So before that, we will look at what are generics. So it provides compile time type safety. So what is compile time type safety? If you look at this, so let's say ArrayList. If you look at here, you can see some warnings. ArrayList is a raw type. References to generic type ArrayList of E should be parameterized. That means it is expecting us to inform what type of elements you are going to store inside an ArrayList. For example, here I have stored all integers. So I can mention the generic type of an ArrayList to be an integer, something like this, within the angular brackets. So when you specify the generic type, you can see the warnings vanished. So when we use iterator here, so first point is it provides compile time safety. And when you use iterator, like just now we have used iterator saying al dot iterator would give me an iterator object. So capture it in iterator I. And while I dot has next, we are saying I dot next get the element and store it in an integer o equals to I dot next, and here we are printing the value of o. So here you can see I dot next, it is asking us to perform typecasting. So even I use integers here for storing integers into an array list. I also have to mention the generic type for the iterator. That is, the iterator will always get integer values. So here, when you look at this, I need not typecast. So when I try to store a string value here after mentioning the generic type like Vikas, you can see a compile time error. That is, it is not allowing us to store strings because we have mentioned that ArrayList is an object used to store integers. So that's the basic advantage of using generics. Provides compile time type safety. For example, if you're not using any generic type here, that is ArrayList can hold heterogeneous objects, then it doesn't show me any compile time error even though I'm storing a string. But when you are retrieving elements, let's see, we are getting a runtime error saying class cast exception. String cannot be cast to an integer because when we are retrieving element by element from an iterator, when I say I dot next and I'm capturing in an integer, but when I get a string, that string cannot be converted into an integer. So that is the reason we got a runtime error. So if I mention a generic type here as integer, we can avoid that runtime because we are getting the error at compile time itself. So that is the biggest advantage of using generics. It provides compile time type safety, and also we need not cast while reading when we mention the generic type. For example, we did not mention any generic type here, and when we added string to a list object, and when we are retrieving, we are capturing it an integer, we got a runtime error. Just now we have seen class cast exception. But when we use generics as string, we need not get a runtime error. Instead, we get a compile time error itself. So that's an advantage of generics. So how to use this list iterator? Basically, it's a child interface of iterator, and it's a bidirectional cursor. That means I can go to the next element in the collection object as well as the previous element in the collection object. And it can perform replacement and addition of new objects also while traversing through a list object. And moreover, how to create list iterator object is using list iterator method on the collection object. So one biggest disadvantage of list iterator is it is applicable only for list objects. We cannot use it for set or map objects. And next is map interface, basically used to represent a group of objects as key and value pairs. So both keys and values are of objects, in which duplicate keys are not allowed but values can be duplicated. So of course we have seen that map is not a child interface of collection because it represents objects as key value pairs, and each key value pair in a map interface is called an entry. So let's see an example of it. Let me create another class inside collection sample, say map demo, with a public static void main and within a package com.educators. So under map interface we have got HashMap. So HashMap hm equals to new HashMap within a package java.util. So import a package util. Next we can add into the HashMap using a method called put. And you can see object, both key and value pairs are objects. So I just use keys as strings and values as integers. So first I use a string for Ramu. I'm storing the roll number as 1. So normally we say that HashMap is used in an applications like when we want to store roll numbers and student names, or when we want to store the cricket scores of the cricketers. So in such applications we go for key value pairs. So for that we can go for hash maps. Similarly, I add another element into hash map. Say for Vishal, the roll number is some 20. And for printing, I just use #hm. So run as Java application, we can see Vishal 20 and Ramu 1 got stored into the hash map. And here I said like it doesn't allow duplicate keys. For example, if I'm trying to enter hm.put of same Ramu with another value, say 34, and run it, we cannot see the earlier one, that is Ramu 1 gets replaced by Ramu 34. That is HashMap doesn't allow duplicate keys. But of course values can be duplicated. So that's all with the session. Thank you.